Okay, this is note 6.2, naming compounds. This is the worksheet that was given. Okay, so before we did this in our notebook, and now we'll just do a few more examples together here. First of all, what is a salt? A salt is just another name for any ionic compound. Any ionic compound is a salt. NaCl, table salt is NaCl. NaCl, sodium chloride, okay? And here's some characteristics of salts. They're typically hard solids with high melting points. Let's just go ahead and do this. I'm going to cross it out. You don't have to necessarily memorize that. Know that it's there, but just don't focus on that, okay? If an ionic compound dissolves in water, it's said to be soluble and it breaks up into its ions. That's correct. If in an ionic compound, the positive and negative charges cancel each other out for a neutral compound. If you use more than one of these ions, use subscripts. If you use more than one polyatomic ion, use parentheses. To name an ionic compound, write the name of the cation and the anion. If the cation is a metal that forms multiple ions, use Roman numerals to indicate the charge. Okay, we'll get to that later. That's going to apply to these two right here, but in that one as well. I may or may not have you do that, I don't know. Okay, calcium oxide. Calcium oxide. So here's the chemical formula, CaO, or rather CaO. We don't need to put a 2 there. Calcium oxide. Ca and Cl, well, that's calcium. Notice it's got a -1 charge here, +2 there, so CaCl2, calcium chloride. Calcium 2+ charge, NO3-. Go to your list here, nitrate. Okay, nitrate, it's got a -1 charge. So calcium, and here's your nitrate. You need 2 of these nitrates. So I'm going to put NO3, 2. Calcium, oops, calcium nitrate. Ca2PO43. Well, PO43- is a phosphate. That's phosphate. PO43-. Okay, so calcium, we've got 2 here and a -3 there. So the common denominator between those two is going to be 6, right? So I'm going to put Ca3. That's now gives that a +6 total. And I'm going to need 2 of these PO4s. PO4, 2. Calcium phosphate. Na2O. The cation in this case is sodium, Na+. The anion is oxide, O, and that's a 2-. Sodium oxide. AlC2H3O2, and there's 3 of them. Okay. Well, if you look here, it's just aluminum. It's right there on your list. That's aluminum. And it's got a 3+ charge. C2H3O2 is acetate. And there it is right there. And acetate has a -1 charge. Acetate, -1. C2H3O2, it's got a -1 charge. Aluminum, let me see here. Yeah, that's okay. Aluminum acetate. Oops. Let me just try that again. Aluminum acetate. Now, in the case of copper and iron, if you look here, iron can form either a +2 or +3, and copper can form either a +2 or +1. Excuse me, my battery's about to die. Okay, and so that's what this last bullet point here is discussing. If the cation is a metal that forms multiple ions, use Roman numerals to indicate the charge. Well, that's what they're talking about. They're saying, hey, look, copper can either be copper 2 or copper 1. And iron can either be iron 2 or iron 3. And it's your task to figure out which one of those it is. Well, if we look at the anion here, which is chloride, it's got a -1 charge. There's 2 of them, and there's only 1 copper, so that tells us that this copper must have a +2 charge. Okay, this is the only tricky part where you kind of have to work backwards. So now what you have to do, because copper could either be copper 2 or copper 3, I'm sorry, copper 2 or copper 1, you have to indicate it by saying copper 2, copper 2, chloride. Okay, let's try the same thing with iron, and in this case we've got a carbonate. Let's see if we can find a carbonate. There it is. Okay, carbonate or carbonate is CO3 with a 2- charge. So you have to look at the anion first, which is this guy. And it's CO3, oops, CO3 with a 2- charge. Again, there's only one of these. How do I know? Because there's no parentheses there to tell me that there's more than one. So 2-. This iron then must be a 2+. See how I worked backwards? There's only one of them. So iron 2 carbonate. Iron 2 carbonate. Where do I have to worry about Roman numerals? Well, it tells you right here on your chart. There's only a few of them. There's only copper, iron, tin, and mercury. Those are the only ones you need to worry about that are a little bit tricky. That concludes, then on 6.2, you know, we can get to naming covalent compounds later. Okay, I think that's too much information for one unit. We'll get to covalent compounds. They're not difficult to name. It's very simple. Okay, you just name them using these prefixes. So tetraphosphate, decaoxide, dinitrogen monoxide. All right, that concludes that.